Hello friends, welcome to the channel CLAYDEN.
Hello friends, welcome to the class Chemoland. Today we will learn about the Wolff-Kishner reduction. This is a reduction type of reaction where a carbonyl compound is reduced. A carbonyl compound is reduced. This is basically CH2 which has been reduced. So this is our reactant and this is our product. Our product has been reduced. So what is the requirement of this Wolff-Kishner reduction? So the Wolff-Kishner reduction is an organic reaction used to convert an aldehyde or ketone to an alkene using hydrogen, base and thermal conditions. Using hydrogen base like KOH or NOH you can use, and thermal conditions. So the Wolff-Kishner reduction is an organic reaction used to convert an aldehyde or ketone to an alkene using hydrogen, base and thermal conditions. So what is the mechanism? Let's see the mechanism. The mechanism of Wolff-Kishner reduction is, so let's take an example, a suitable example. So this is basically a ketone molecule. This is today's our starting material which will be reduced at the end of the day. So we will use hydrogen NH2 and base like potassium hydroxide and a thermal condition. So let's go into the mechanism. So hydrogen will connect here and our base hydroxide anion will deprotonate the compound and will form like this. NH minus. This minus will push back and here will come a negative charge on the head of carbon. Like this the mechanism goes on. A carbon ion. This carbon ion also protonated by the help of with the help of water molecule. This NH. So another hydroxide anion. Again deprotonates the molecule, deprotonates the compound. So now the forms this negative charge will again push here and like this the nitrogen will go up. So now our compound will be like this. And again like the previous it will be protonated with the help of our water molecule, and finally the compound has reduced. Finally the compound has reduced. This is the mechanism where a ketone molecule or an aldehyde molecule reduced with the help of hydrogen and a base and in a thermal condition. This is the mechanism of Wolff-Kishner reduction. This is the mechanism of Wolff-Kishner reductions. So these are the examples of Wolff-Kishner reduction, where with the help of hydrogen and potassium hydroxide and heat, we can reduce a carbonyl compound like aldehyde or ketone. So first let's solve this question. Here you can see easily that there is a carbonyl group and this is a ketone molecule. This part, ketonic part, this is a ketonic part, and with the help of hydrogen and potassium hydroxide and ethylene glycol and with the help of heat, we can easily reduce the molecule. So let's solve it. PHO. So this part going to be reduced, so you can highlight it these hydrogens because it is reduced, and rest of the molecule as well same will remain same. Okay, this has been solved. Now next, so here is a carbonyl group, so you can reduce with the help of hydrogen, potassium hydroxide and heat. So let's solve it. So it has been reduced and rest of the molecule will remain same, CH3, and here is a methyl group. This has been solved. Now here check that here is a aldehyde, CHO aldehyde, where the C double bond O is present, so you can easily reduce it with the help of hydrogen, KOH and heat. So this is basically a Wolff-Kishner reduction. So let's solve it. OME, and this after reduced it's going to be a methylene group, and this methyl SPH. Okay, this has been solved. So it's this three of them are Wolff-Kishner reduction. You can write short WR reduction. Whenever you see there is a carbonyl compound like aldehyde or ketonic part, and there is a present hydrogen and a base and heat thermal conditions, you can easily treat the reaction as Wolff-Kishner reduction. So here you can see there is a ketonic part, so you can easily reduce it, CH2 4. So this going to be CH2 because it has been reduced. Okay, this has been reduced. So these all are the examples of Wolff-Kishner reduction. So practice at your home, learn and hard work. Thank you.
Hello friends, welcome to the channel ChemoLab.